Hello and Assalamualaikum everyone. My name is Khalida. Today I am excited to take you under the hood of one of the most powerful consumer processors on the market, the Intel Core i9. So this is my group member, Adlin Sofia, Zamil, Muslihuddin, Alia, and Wahida.
Hi, my name is Alia. I will be talking about the Intel Multi-Core i-Series processor that we've only focused on the Intel Core i9. The Intel Core i-Series is Intel main processor family that is used in desktop, laptop, and workstation. This processor uses a multiple architecture, which means they have multiple processing cores on a single chip to handle more tasks efficiently. They also include advanced technology such as hyper-threading, turbo boost, and large cache memory to improve speed and overall performance. The Intel Core i-Series is divided into four categories, which is Core i3, Core i5, Core i7, and Core i9. As we move from i3 to i9, the processor provides higher performance, more cores, and additional features for demanding application. The Intel Core i9 is the most powerful processor in the Intel Core i-Series. It is designed for professionals and users who needs very high performance with up to 24 cores and 32 threads. It can multiple heavy applications smoothly. Its high clock speed and large cache memory make processing faster and more efficient. Therefore, the Core i9 is commonly used for 3D design, video editing, high-end gaming, and other demanding tasks. So what is Intel? Intel Corporation is the company behind the Intel Core i-Series processor that was founded in 1968 by Robert Noyce and Gordon Moore, and is based in Santa Clara, California. It is one of the world's leading semiconductor companies, known for producing microprocessor and chipset that power most of our personal computers, server, and embedded system. What has kept Intel at the forefront industry is its continuous drive to innovate, constantly improving its processor design and manufacturing processes. Because of this, Intel has remained one of the most influential and recognized names in modern computing today. Purpose. This processor is built for users who needs higher level of performance. It can efficiently handle gaming, video editing, 3D rendering, and other intensive tasks. Its high core and threads count allow smooth multitasking, while its advanced technology and high clock speed deliver excellent overall performance.
My name is Nurul Wahida. I will continue with a central processing unit of Intel i9. Intel Core i9 is the highest performance processor in the Intel Core i-Series family. One of the main features is the Intel hybrid architecture. It consists of 8 performance cores, which is P cores. It handles demanding application and single-threaded tasks. It optimized for high-speed processing and intensive workload. Next, it consists of 16 efficient core, E core. It handles background tasks and improves multitasking with lower power consumption. It combines high performance with power efficiency. It executes background processor and parallel tasks efficiently. Number 3 is 36 MB shared L3 cache. It stores frequently used data to reduce memory access time. It shared among all processor core. For the ring bus, it high-speed communication pathway connecting all core and cache. On core, it functions to contain memory controller, PCIe controller, and other system management component. For XELP integrated graphic, or we known as iGPU, is built-in graphic processor for display output, multimedia, and light graphic workload. Next, what is register? Registers are the smallest and the fastest type of memory in the Intel Core i9 processor. They are built directly inside each processing core, which allow extremely fast access with the very low delay. Their main function is temporarily store instruction, data value, memory address, and intermediate result, while the CPU is processing tasks. In this architecture, each core has its own private register file. This means registers are not shared between cores, so every core can work independently and efficiently. For the function and performance of register. Firstly, during the program executing, data is first loaded into register file before any calculation happen. The execution units such as arithmetic logic unit, ALU, and floating point unit use this data to perform operation. Because registers are inside the CPU core, they can access in almost one clock cycle, making them extremely fast compared to cache memory or RAM. This fast access reduces processing delay and improves overall performance since each core has its own register. The processor can run multiple tasks at the same time, enabling strong parallel processing and better multitasking performance, especially for heavy workload like gaming, video editing, and data processing. Next, for the clock speed and timing, is the operating frequency of the Intel Core i9 processor, and it is measured in gigahertz. 1 gigahertz means the process performs 1 billion clock cycle every second. A higher clock speed generally allows instruction to be executed faster. Each clock cycle consists of a high and a low voltage signal that synchronize CPU operation and enable instruction execution. The Intel Core i9 operates a base clock frequency, which provides stable performance under normal workload while remaining within its thermal design power. However, clock speed alone does not determine processor's performance. Other factors such as the number of cores, cache memory, processor architecture, and memory bandwidth also contribute to the overall performance. Intel Turbo Boost technology is a built-in feature in the Intel Core i9 processor that automatically increases the processor speed when more performance is required. It works by boosting the CPU frequency, its best clock depending on system conditions such as workload, temperature, and power availability without any manual setting needed from the user. For example, the Intel Core i9 13900K runs at the base frequency of around 3.0 GHz, but it can increase up to 5.8 GHz using Turbo Boost. This allows the process to handle demanding tasks such as gaming, video editing, 3D rendering, software development, and engineering simulation more efficiently. When the system is under light usage, the processor automatically reduces its speed to save power and control heat. Overall, this technology helps balance high performance and energy efficiency in Intel Core i9 processor.
For the next slide, we cover about the evolutions of the system bus. In early computer setup, the CPU had to talk to the memory through the external component called the notch bridge, using a shared power of way known as the front side bus or FSB. However, as clock speeds and core can grow, this shared design become a massive bottleneck. Because of that, too many data transfer had to fight for the same line. To completely fix this, the Intel Core i9 uses an integrated memory controller, or we can call it IMC, built directly onto the CPU die itself. By utilizing high speed, point-to-point path away, it eliminates legacy traffic congestions, allowing to the Core i9 to support advanced DDR4 or DDR5 memory at maximum efficiency. Now, moving inside the silicon chip itself, how do the component communicate? For the Intel Core i9, it uses optimized ring bus architecture. You can think of it as a bidirectional key-cooler. Highway connections, the PCOS, ECOS, integrated graphic, and the edge chips. So the data travel along this loop and access a specific ring stop, using the shortest possible path to keep latency ultra low. Now, you might wonder about mesh architecture. So, mesh is a grid structure used a heavy enterprise or server chips like Intel Xeon. Because a simple ring will introduce too much delay when you have massive core counts. But for a consumer desktop flagships like the Core i9, the ring bus remains as a kings because it delivers the actually lowest data retrieval latency. Next, let's look at the express link. When a slow device go to the PCH, high performance component get a direct line straight to the processor. Modern Core i9 architecture features dedicated process allocate PCIs lane that completely bypass the chipsets. This cut out any intermediate process layer or delays. This direct connection is specially designed for a bandwidth-intensive hardware. For example, discrete flagship GPU can continuously stream massive volume of 3D texture data straight from the system memory. Similarly to the ultra-fast NVMe database, workloads or 8K video footage with zero delay. This setup ensures your most critical hardware runs at full serial speeds without being bottlenecked by the chipset. Next, let's look at the Core i9 chart memory system. To prevent the fast CPU formatting on a slow system RAM, it uses a built-in 3-level hierarchies. Starting at the top, the level 1 chart is the faster layer located inside each core. As shown, it is built into a 32 KB instructions chips and 48 KB data chips for instance access. Moving to the middle, the level 2 chips provide a dedicated 2.0 MB private block exclusively for every performance core. This keeps heavy tasks like gaming or rendering running very smoothly. Finally, at the base, we have the level 3 Intel Smart Chats. This acts as a massive 36 MB share pool that is dynamically distributed across all cores using a high-speed ring bus. In short, this pyramid structure drastically reduce latency and ensure seamless multitasking without relying too much on the slower main RAM.
My name is Ahmad Zamil and I will be presenting about instruction cycle for our CPU. So, what is instruction cycle? It is a fundamental process that allows processor to execute program instruction. Every task performed by the computer, whatever is opening an application, browsing internet or playing games, it relies on this continuous cycle. Instruction cycle consists of 3 parts stages, which is fetches, decode, and executes. These stages work together to retrieve, interpret, and process the stored instruction efficiently. To achieve high performance, our CPU or Intel Core i9 enhance this process with technologies such as pipelining, cache memory, allowing the processor to execute billions of instructions every second. Next, I will explain the fetch stage, which is the first stage of instruction cycle in the Intel Core i9 processors. During this stage, the processors retrieve the next instruction from the memory, the program counter or PC, hold the address of that instructions and send it to the memory address register (MAR). The instruction is then moved into the MDR memory data register and loaded into the instruction register IR for decoding. To improve speed, our Intel Core i9 use its L1 instruction caches which store frequently used instructions closer to the processors. This reduces delays and help the CPU works more efficiently. In short, the fetch test is responsible for finding and retrieving the next instruction before it moves to the next decode stage.
My name is Muhammad Syuddin bin Muhammad, and today I will present about decode stage, execute stage, data processing, and CPU workflow. The decode stage is where the instruction stored in the instruction register, or which is IR, is interpreted by the control unit. During this stage, the processor identifies the opcode and operands, then prepares the instruction for execution by converting it into a form the processor can handle efficiently. First, the control unit reads and interprets the instruction stored in the instruction register, or IR. Next, it identifies the opcode, which tells the processor what operation to perform, and the operands, which are the data or memory locations needed. Then, the instruction is translated into small micro operation, also called mu ops, so the processor can execute it more efficiently. Finally, everything is ready and the instruction is passed to the execute stage for processing. For the execute stage, it is responsible for carrying out the operation specified by the decoded instruction. After the instruction has been decoded by the control unit, it is sent to the appropriate execution unit within the processor. During this stage, the processor performs the required operation and generates the result for further processing or storage. And for the last part, which is data processing and CPU workflow, the Intel Core i9 processor improves instruction processing by using several advanced technologies. These technologies help the processor work faster and more efficiently. First, pipelining allows multiple instructions to be processed at the same time, instead of one after another. Second, the L1, L2, and L3 cache stores frequently used data, which reduces the time needed to access memory. Third, branch prediction helps the processor predict the next instruction, reducing delays and improving the flow of execution. In addition, out-of-order execution allows the processor to execute independent instructions earlier instead of waiting, which improves processor utilization.
To summarize, the Intel Core i9 is the ultimate no-compromise processor. On the plus side, it delivers industry-leading speeds and massive multitasking power that drastically slashes production times for professional creators and gamers alike. However, it does come with trade-offs. It demands a lot of power, generates extreme heat that requires premium liquid cooling, and carries a high price tag. Ultimately, if your work demands maximum speed and every second counts, the incredible architecture of the Intel i9 completely justifies the premium. That's all from us. Thank you.